So, since 2000, the world has been hit with more than 1,700 earthquakes with magnitude greater than 5. Many happened around the Ring of Fire, located around the Pacific Ocean. In North America, the biggest threat is the San Andreas fault line, which can create an earthquake of a magnitude higher than any other, earning it the spine-tingling nickname, the Big One. The potential destruction of California is a terrifying prospect that could have unimaginable consequences. But the Big One is just the beginning of what's to come. Bad news! Scientists have predicted an earth-shattering event that will occur in 2030. Like it or not, there's a 70% chance that we'll experience the Big One, and it will be an earthquake with a magnitude of 6.7. The San Andreas fault line will cause the Big One, but what is scary is that we can't predict it. On the other hand, a massive earthquake occurs every 100 years. This means there's always time to prepare for a natural disaster. If we traveled back in time, we'd see a few significant earthquakes like the ones that wiped out San Francisco and Fort Tejon. Buildings made a long time ago are not quake-proof. They will collapse. Even if they survive, you should not enter them. But buildings are not the most dangerous part. You should watch out for electrical lines and gas pipes. Your hill house might be lovely, but it is extremely unsafe. During quakes, the hill can turn into a massive landslide that will destroy everything in its path. Say goodbye to road trips because all the roads will be ruined. You should have some spare water and food since you won't be able to go to the supermarket. This disaster won't be cheap. It will cost the U.S. around $200 billion to recover from the quake. At least the earthquake will not trigger tsunamis. But there's something it can cause more damage than the Big One. The notorious Cascadia subduction zones start in California and ends up all the way in Vancouver, Canada. The San Andreas fault line is nothing compared to this zone. It can wipe the whole coast off the face of the Earth, an example of hyperbole. Subduction zones are tectonic plates forced to be one under the other and constantly pulling apart. One is called the North American Plate and the other is the Juan de Fuca Plate. Zones like these are not to be messed with, since they are terrifying hotspots for earthquake activity and extremely dangerous because they cause massive underwater quakes. But they are underwater, so what can they do to us? Well, they can cause giant tsunamis, flooding cities, and destroying the coastline. Right now, the most active zone is the Ring of Fire. The Cascadia zone might be less active, but it is like a sleeping beast that can wake up and destroy everything in its path, causing a groundbreaking earthquake. The last time all this stress was released was in the year 1700. Unlike the San Andreas quake, this one will cause massive tsunamis and much bigger shocks. Let's hope you'll be camping in an open field at that time, because most buildings and bridges will likely be destroyed. Also, be ready for the aftershocks, as they'll be devastating. Nature won't be spared either. Landslides will change animals' habitats. Even our homes will be changed forever. Luckily, there is a light at the end of the tunnel, and scientists are doing everything they can to ensure our safety. New rules are implemented. Every new building must be able to withstand massive shocks. They're developing modern warning systems, and every new infrastructure must follow strict quake-proof guidelines. The Juan de Fuca and the North American plates are locked together, but they won't stay like that forever. When they unlock, get ready for a massive shake. The closer you are to the epicenter, the more damage you'll experience. But even if you are lucky to be far away, you may still feel the ground shaking for some time. Now, if we compare the Cascadia subduction zone and the San Andreas fault, we'll see how much more dangerous the Cascadia zone is. In 1994, there was an enormous 6.7 magnitude earthquake in the Northridge area, close to the San Andreas fault. Sadly, many people didn't make it, and some were injured. Back then, buildings were not strong and earthquake-proof, and many of them were damaged. The Cascadia subduction zone can potentially cause a magnitude 9 earthquake. A magnitude 6 quake has the power of around 44 million pounds of dynamite, but a magnitude 9 has the power of 44 trillion pounds of dynamite. The strongest ever recorded quake was in Chile. Its magnitude measured 9.5, and it destroyed most everything. So let's say you've survived the quake, but the struggle is far from over. Soon after, a massive tsunami will strike, with waves that might reach up to 100 feet in some areas. That's so unlike the San Andreas earthquake, which can't produce any significant waves. So say goodbye to your beautiful garden, since salt water will destroy trees and plants, changing the environment for a period of time. The only positive thing will be you won't need Halloween decorations, because all those dried-out trees will resemble a ghost forest. The combination of waves, quakes, and the sheer size of the area will make this natural disaster much more dangerous than any caused by the San Andreas Fault or the so-called Big One. A quake similar to this happened around 300 years ago. Many more have been recorded in the past 3,500 years, proving that they continually occur every 400 to 600 years. So, technically, we have around 100 to 300 years before the next big one hits. We still have no idea how exactly the Cascadia subduction zone works, because we discovered it in 1970. This zone is super scary because it can cause big earthquakes. It was found by accident when researchers studied the Ring of Fire. They wanted to know if this area had caused any trouble in the past years, and the proof was under their noses. In Washington, there is a horror forest where nothing has been growing for years. When researchers tested the soil, they found a tremendous amount of salt. They put two and two together and concluded that a massive tsunami had been the reason. Experts still didn't know when the forest was destroyed. But Japan kept records of a gigantic earthquake that had a similar effect. It was the one that happened in the year 1700. There is a 1 in 3 chance that the next one will occur in 2050. You must know how to survive the Canadian earthquakes and make it out unscathed, so listen carefully. Those who live in this area have almost no experience with earthquakes like this one. Surviving the quake is relatively easy, but the tsunami coming afterwards is the real danger. After the shake, find the highest ground and go there. Only bring the essentials, like food and water. Yeah, leave your baseball card collection at home. After the first hit, don't try to go down. Seismologists say that most likely there will be a few more waves, and they have proven this. On the 22nd of May, 1960, seismologist Jerry Eston and his 4 friends went to Hawaii to see an expected tsunami that was to happen around midnight. They set up their gear on Wailuku Bridge with an escape route planned. This bridge had been destroyed in the previous tsunami, but the new one was much taller and better. After midnight, the water was 4 feet above the average level. The second wave hit a half hour after midnight, and the water rose another 9 feet by 1 a.m. The water started going down and dropped by 7 feet, but the horror was far from over. Next, they saw a wave that was around 20 feet tall. This shows us that tsunamis are unpredictable, and we should listen to experts to stay safe. There is a powerful force hiding underground where tectonic plates meet, and one forces another under it. This happens in the Pacific and Indian Oceans. Strain builds over centuries. The tension is unbearable until the megathrust awakens. The Earth shakes with a magnitude that can exceed 9 points, more powerful than any other earthquake. When the seafloor suddenly gets pushed up fast, it sends a huge ripple across the water, and a tsunami of huge force is out. These waves are called teletsunamis, and they cross entire ocean basins, ready to take over coastlines thousands of miles away. The thrust fault stretches over 600 miles. The Earth is not just shaking, it feels like it's tearing apart. This is the power of a megathrust earthquake. Those caught in its path will have to fight for their lives. Japanese authorities recently had to issue their first ever Megaquake advisory. It happened because of a strong tremor on the edge of the Nankai Trough ocean floor zone. In the end, most of the warnings were lifted, and there wasn't much damage from the 7.1 magnitude earthquake. Parts of southwestern Japan started to shake, and the superfast trains in Japan slowed down to stay safe, which made travel slower for everyone. But everyone is staying alert as they know about the risk of a megathrust earthquake that could happen within the next few decades in the Nankai Trough. The tectonic plate under the Philippine Sea is slowly sliding underneath the land where Japan is, moving just a few inches every year. The last big earthquakes from this area happened in 1944 and 1946, both with a magnitude of 8.1. These quakes have caused a lot of destruction in the country. The next megathrust earthquake in the region, if it does happen, could be between a magnitude 8 and 9. Scientists still can't agree on how likely this mega earthquake is to happen, but it could be up to 80% certainty. On the other side of the Pacific, scientists from the U.S. Geological Survey have studied a dangerous area along the U.S. West Coast. It's called the Cascadia Subduction Zone, and it stretches from northern California to northern Vancouver Island in Canada. Over the past 14,200 years, there have likely been at least 30 big earthquakes in this region. One major quake happens every 500 years on average. But for a long time now, Cascadia has been quiet, and it worries scientists. They think this might be because the area is locked, meaning the tectonic plates are stuck together and building up a lot of pressure. Eventually, the part of the seafloor could suddenly break and move by several feet. The shaking would be just 5 minutes, but it would create a powerful tsunami as the seafloor shifts that would last for 10 hours. If it happens, it's going to be the worst natural disaster in the country's history, according to experts. The ground on some inland hills could turn into something like quicksand. This would cause the hillsides to slide and crumble, taking down roads and bridges. Around 620,000 buildings could be badly damaged or even collapse, including about 100 hospitals and 2,000 schools. People in Washington state might have to take care of themselves without help for 2 weeks, finding food, water, and shelter on their own. Scientists are studying slow slip events, where the tectonic plates move very slowly over weeks or months, releasing some energy but not enough to stop a big one. Every time the magnitude of an earthquake goes up by just one number, the energy it releases is 40 times bigger. So we'd need about 1 million small earthquakes every day for 500 years straight to release the same energy as one huge magnitude 9 earthquake. But these small earthquakes might be clues that a bigger earthquake is coming. To better monitor the Cascadia Fault, experts are mapping the fault more accurately and adding better monitoring tools offshore. Scientists receive over $10 million to install seismic sensors and seafloor pressure gauges on a fiber optic cable off the coast of Oregon. The goal is to be ready to warn people and potentially save lives when a big earthquake strikes. A sharp megathrust earthquake happened in this part of the world in 1964. It went down in history as the Great Alaska Earthquake and had a magnitude of 9.2. It lasted for more than 4 minutes, making it the most powerful earthquake in the history of the U.S. and North America. The ground shook so hard that it caused huge cracks and landslides. In Anchorage, many houses, buildings, and roads were destroyed because they weren't built to handle such a big earthquake. In some places, the land was permanently changed. For example, the coastline near Kodiak and Hinchinbrook Island was lifted by 30 feet. In other areas, like Gerwood and Portage, the ground sank by 8 feet. They had to rebuild roads higher so they wouldn't be flooded by the tide. A huge 27-foot tsunami wiped out the entire village of Chiniga. Many coastal towns were heavily damaged, not just by the earthquake, but also by tsunamis and the fires that followed. After the main earthquake, there were thousands of smaller aftershocks for months. A moderate earthquake of magnitude 4.4 shook Los Angeles in August 2024. Once it was over, the LA Fire Department checked around the city and didn't find any major damage or anyone hurt. In the nearby city of Pasadena, which is close to the earthquake's epicenter, a water pipe burst inside City Hall and everyone had to leave the building. Thankfully, there was no danger of a tsunami. The best we can do to avoid panic in such situations is to be prepared. Japan is one of the places on Earth where earthquakes happen the most because it sits on the edges of 4 tectonic plates. Around 1,500 of these earthquakes each year are noticeable. Because of this, the people in Japan have learned to live with earthquakes. The 1950 law set a rule that buildings should be able to handle earthquakes up to a magnitude 7 without falling apart. An update 30 years later said that buildings should only have minor damage in such earthquakes and still work as usual. But if an earthquake is even stronger, the law says the building's main job is to not collapse and save people's lives. At the most basic level, buildings are made stronger with thicker beams, pillars, and walls so they can handle shaking better. Another technique is placing special pads made from materials like rubber at the base of a building. Some buildings are even built on thick layers of padding that separate them from the ground completely, which helps protect them during an earthquake. A skyscraper might sway back and forth a lot, moving up to 5 feet. To stop it from getting damaged, engineers can add something called dampers every second floor all the way to the top. These dampers are like giant bicycle pumps, but instead of air, they're filled with liquid. When the building shakes, the dampers push against the liquid inside them. Even though the liquid doesn't squish very much, it can still absorb some of the shaking. When they're building tall skyscrapers, engineers try to make the structure as simple and balanced as possible. This means having each floor the same height and placing the support columns evenly. But sometimes, architects who design skyscrapers don't want to make these compromises because they have creative ideas for how the building should look. Then they have to find compromise solutions. For example, Tokyo's Skytree Tower, one of the tallest buildings in the world, is designed in a futuristic style but also includes special features to protect it from earthquakes. It has a central pillar, like in traditional Japanese pagodas, and seismic dampers that help absorb the energy from an earthquake, keeping the building safe.
A magnitude 15 earthquake has the potential to completely destroy our planet and evaporate all the water in a matter of seconds, leaving Earth uninhabitable. Over 500,000 earthquakes happen annually, but none have a magnitude of 15. 90% of quakes occur in the terrifying Ring of Fire zone located around the Pacific Ocean. The ground there is like jello. It shakes almost constantly. The most powerful earthquake to have ever struck Earth had a magnitude of 9.5. That much power can lengthen or shorten the day. But there's probably an earthquake in the confines of your own home now caused by a speck of dust landing on a table. But it has a power of negative 15 magnitudes. Earthquakes happen when tectonic plates move. They're like Lego pieces that are not properly secured, and when they move up, down, or hit one another, the ground also moves, triggering earthquakes. This tectonic energy acts like a battery. It stores energy for a long time, up to 500 years. When this stored energy is released in a sudden burst, the consequences are horrifying. Even the strongest structures submit to this relentless force that leaves a trail of destruction in its path. In some instances, earthquakes can even trigger tsunamis, amplifying the chaos. Such a crazy amount of power can split the ground open and cause severe damage. The strength of an earthquake is measured by the Richter scale, but now it's being replaced by the moment magnitude scale. When there's an earthquake, we hear about how strong it is. It's usually from 1 to 10. Luckily, we haven't had a Richter scale earthquake yet. The most powerful earthquake to have ever happened in modern history occurred in Chile in the 60s. It was around 9.5 on the Richter scale, and it altered Earth's rotation and messed up the length of the day by around 2 milliseconds. It also triggered a massive tsunami and affected a vast area of 155,000 square miles. The Richter scale doesn't actually have a limit. Still, anything above 25 doesn't need measuring because if that ever happened, we would simply turn into dust, and nobody would care to measure this disaster. As we said, the strongest earthquake had a magnitude of 9.5. If this magnitude had been just 0.5 stronger, it would have created a ruptured line 2,174 miles long. That is almost 7 times the size of Wyoming. A magnitude 11 earthquake would create a crack halfway around the world. Massive tsunamis would hit coastal areas, destroying everything, and Earth would get into a massive environmental crisis. If you love hiking, you would have new mountains to explore. created by the terrifying earthquake. Even the temperature would increase because of volcanic eruptions and the resulting greenhouse gases. It would turn our planet into a hot oven. The safest places would be far away from any buildings, seas, oceans, and mountains where there would be a low chance of a landslide. Countries unprepared for earthquakes would be totally destroyed, and cities would turn into piles of rubble and dust. Going up on the Richter scale would only make things worse. But don't worry, an earthquake of that power is impossible. Earth's crust doesn't have enough energy to produce such earthquakes. But there is something that has much more power and can produce mega earthquakes. Asteroids are powerful enough to destroy our planet, as we all know from the dinosaur era. That asteroid was around 6 miles long and it caused massive damage to the planet. It triggered earthquakes that shook the ground constantly for months. These terrifying quakes were about 50,000 times stronger than the Chile earthquake. They also triggered a tsunami that was 30,000 times more powerful than the Indian Ocean tsunami. And the latter was one of the most devastating tsunamis to have ever struck Earth. The earthquakes caused by the asteroid had a magnitude of 11, making it the most powerful and scariest natural disaster ever. And let's hope it stays that way. The Indian Ocean tsunami affected only certain areas of the world. Meanwhile, the asteroid tsunami affected every part of the world and had 33-foot-tall waves. Even if you had traveled to the most remote place on Earth, you wouldn't have been able to hide from this Grim Reaper. A 15-magnitude earthquake wouldn't be 15% stronger than the Chile earthquake. The scale doesn't work like that. It would be around 100 million times more powerful than a 9.5 magnitude quake. It could make all the water on Earth evaporate, leaving us devastated and without any H2O to survive. All ecosystems would collapse, all food chains would be broken, and only some super strong bacteria would probably survive the impossible. That is only a fraction of the frightening things that could happen. The ocean is like the AC for our planet. Without it, Earth would be super hot. The ocean also serves as a shield from the sun's powerful rays. It acts as a heat absorber and cools Earth. Scientists think that the most dangerous thing would be the inability of Earth's crust to survive the violent shakes of the 15-magnitude earthquake. If our planet miraculously survived and didn't turn into dust, there would be massive openings in its crust. The ground would become gelatinous. It would randomly move up, down, left, and right, and no building would survive that. Our civilization would be brought back to the Stonehenge era. Tectonic movements like this are devastating. A similar thing happened in Japan when tectonic plates moved 165 feet from each other and then snapped back together, creating a 9-magnitude earthquake. No place on Earth is immune to this bone-chilling natural phenomenon. Still, certain places have higher chances of being destroyed than others, like the Ring of Fire, where 90% of earthquakes happen. This is a place where earthquakes are almost everyday occurrences. The Ring of Fire is located in the Pacific Ocean. It forms a ring around the continents that surround the Pacific. There, several tectonic plates meet, creating highly unstable ground. To make the problem much more terrifying, 75% of active volcanoes are located in this area. 90% of dormant volcanoes are also there, making this place extremely dangerous. Scientists carefully study this region to find a way to predict when the next earthquake might strike. The Ring of Fire is not the only place at risk of earthquakes. In California, along the San Andreas fault line, 2 tectonic plates have been storing power for more than 200 years. The San Andreas Fault is 715 miles long and has the potential for a massive earthquake. This region has its fear of violent earthquakes like the one that happened in San Francisco in 1906. It had a magnitude of 7.8 on the Richter scale. Scientists' predictions are terrifying. They say that the chance of a 6.7 magnitude earthquake is very high in the area. If all hell starts to break loose, you should know how to survive. Avoid anything that might fall on you, like windows, closets, or unstable ceilings. The official phrase from emergency experts is drop, cover, and hold on. Stay low to the ground. Hide under something stable like a table. and remain there until the shaking stops. Make sure to stay in your shelter for another minute or two, just in case there are aftershocks or loose debris. Use your nose and smell for gas. If you do smell it, don't turn the lights on or do anything that might ignite it. Stay strong and be safe. At this very moment, scientists are getting ready to explore the Earth's deepest layers, where temperatures are insanely high and the pressure is crushing. It might sound like a plot from Journey to the Center of the Earth, but it's for real. By 2026, the Krafla Magma Testbed project plans to drill into an active volcano in Iceland. Their goal is to search for magma. Yep, that boiling molten rock that we often associate with destruction. It is a high-risk mission and a huge technical challenge, but the payoff can transform our future. This isn't our first attempt to journey to the center of the Earth. Back in 1959, Hawaii witnessed a breathtaking spectacle as red-hot lava violently erupted from 400-foot Kilauea Iki crater. Over the next 5 weeks, lava fountains erupted in 17 major bursts, with the tallest reaching a record 1,900 feet. This spectacular and terrifying event left behind a glowing lava lake in the crater. A few months after the eruption, the lava began cooling and forming crusts. That was a perfect chance for scientists to drill into that lake, see what was going on beneath it, and collect data about the magma reservoir. Over the next 2 decades, they kept coming back, digging a little deeper each time. By 1979, they managed to get 173 feet down. Up to that point, it was the closest we had ever come to an actual magma chamber. And by that, I mean the underground pool where magma sits before eventually rising to the surface and causing a volcanic eruption. Decades later, the dream of reaching magma finally became a reality. We are now in Iceland in the year 2009. The Iceland Deep Drilling Project has just kicked off. Their goal is to transform the Earth's inner heat into clean energy for everyday needs, such as heating homes and supplying hot water for baths. You see, using heat from the Earth's interior to make energy isn't new, but it usually comes from hot water underground, not directly from a freaking scorching magma chamber. That's why the Iceland Deep Drilling Project was such a big deal. Magma could be a clean, renewable power source. And since it's hotter than the geothermal energy we normally use, it could generate a lot more power. Iceland is a natural choice for this kind of project. Known as the land of fire and ice, this country is home to some of the most active volcanoes on the planet. One of the most popular ones is Krafla, a volcanic caldera of about 6 miles in diameter, located north of the island. So, the initial plan of the Iceland Deep Drilling Project was to go there and excavate 13,000 feet deep. But something unexpected happened. When they were only 6,900 feet down, the drill hit magma. Wow! On one hand, it was exciting, because, well, we finally found it. And just like that, Krafla became the first place in the world where we know exactly where magma is. But on the other hand, their equipment wasn't prepared or built for it, and the molten rock basically corroded their infrastructure, bringing the project to an end. Instead of being a failure, this accidental discovery gave us a ton of valuable data. We realized that, with the right equipment, drilling in such extreme heat is definitely possible. Scientists found that these underground molten pools can in fact produce a significant amount of geothermal energy. And most importantly, we learned exactly where the magma was. That brings us to the current Krafla Magma Testbed project. This scientific program aims to create the world's first magma center. The idea is to set up a base where scientists can safely work with magma and have all the necessary infrastructure to run experiments on volcanic risks and geothermal energy. So that's like the basic idea. But their real plan is to return to Krafla, drill back into it, and create a gateway to the magma chamber. The goal is to understand its potential for generating energy, study its properties, and see if we can use it safely and efficiently. If they pull this off, it could provide a nearly endless source of geothermal energy for Iceland's homes and buildings. Even though magma is incredibly hot, reaching over 2,000 degrees Fahrenheit, experts say it is safe to take energy from it and believe the process won't trigger another volcanic eruption in the country. They're so sure about this, partly thanks to the Iceland Deep Drilling Project. But this whole process isn't like drilling for oil or gas. It's way more challenging and risky. Magma is not just extremely hot, it's molten rock, which can wreck equipment and pose serious safety issues. Right now, the Krafla Magma Testbed project is in its early stages. Scientists and engineers are working hard to develop the tech needed to drill into magma safely. They're testing new drilling techniques, creating heat-resistant materials, and running simulations to figure out what happens when you actually drill into a magma chamber. They hope that by 2026 they will be ready for the next step, which means going back to Krafla and drilling all the way down towards the magma chamber. It might take 2 months to reach it. Their plan is to drill a single hole that will go right into the magma body and hopefully keep the equipment running there for many years. If they succeed, scientists also plan to add special sensors down there to measure and monitor pressure. This could help predict eruptions better and prevent disasters, like what happened with Mount St. Helens in the United States. In 1980, this volcano erupted, causing massive destruction and claiming over 50 lives. The eruption was so intense that it completely blacked out sunlight in Spokane, Washington, which is about 250 miles away. While that sounds terrifying, it's nothing compared to a super eruption, like the one that happened over 70,000 years ago at Toba volcano in Indonesia. This disaster was about 1,000 times more powerful than Mount St. Helens. Toba is just one of the 20 supervolcanoes on Earth. A supervolcano is what people call a volcano that can produce an eruption of magnitude 8. These eruptions, known as super eruptions, are the largest and most explosive ones. They could have global consequences by affecting the climate and causing widespread destruction. For example, if Yellowstone had a super eruption today, the surrounding states of Wyoming, Idaho, and Montana would be directly affected. They could be hit by hot avalanches of volcanic ash, gases, and rocks that might reach temperatures of up to 932 degrees Fahrenheit and speeds of over 180 miles per hour. This nightmarish scenario is a real possibility, but predicting when it might happen is almost impossible. Volcanoes don't follow a precise schedule, so it is hard to predict when a supervolcano will erupt next. That is also why the Krafla Magma Testbed is so crucial. By examining a volcano's activity from within, scientists could potentially predict eruptions with much more accuracy. As you might have guessed, drilling into magma is definitely uncharted territory, but the potential benefits are huge. Besides providing a clean energy source and making people who live near volcanoes feel safer, this project might also help us learn more about what is beyond Earth. Yep, it could lead us to breakthroughs in space exploration, helping us understand how other rocky planets and moons formed their crust, just like Jupiter's moon Io, which is the most volcanically active world in our solar system. In the end, the Krafla Magma Testbed project is more than just an experiment. It is a bold vision for the future of energy. It's about pushing the boundaries of science and engineering, taking risks, and dreaming big. So we should definitely keep an eye on Krafla, because this adventure into the fiery depths of our planet could end up changing our future.
You've spent your entire life researching microorganisms. Last few years, you've been creating a device that can shrink you in size. And finally, it's ready. At first, you want to shrink yourself to the size of a thumb so you can probably see some microbes with the unaided eye. And then, after more experimenting, you hope to shrink to the size of a bacterium yourself. To make the journey safe, you put on a special suit, similar to a spacesuit. It's equipped with a life support system. You direct a beam from the device at yourself. The beam must change your mass and volume. To return to the previous state, you must stand on a round platform the size of a hockey puck. You put it near your feet so you can easily climb on it when you get smaller. Press the button and activate the machine. Ooh, something's wrong. The device gives an error and you shrink not to the size of a thumb, but 1,000 times smaller, to the size of a bacterium. Oops. You become so small that the fleece of the carpet on which you were standing seems to be the size of huge trees. Now don't panic. You need to find the puck, stand on it, and you'll return to your normal size. It was right next to your feet, just an inch away. Wait, but what's 1 inch now, when 1,000 people your size can fit on the tip of a human hair? You decide to climb the fleece to see where the puck is. You can't see the lab ceiling. The room is out of focus because of its huge size. You're surrounded by thousands of bacteria. They're so different in sizes and colors, but you can identify 3 main forms. Round bacteria that looks like spheres are cocci. They can merge with each other and increase in size. Cylindrical, capsule-shaped bacteria, looking like sausages or bananas, these are bacilli. And spirobacteria are called spirilla. At the end of their body, they have a hair-like cilium. Bacteria are essential for our planet. They help to produce oxygen and absorb carbon dioxide. They purify the water and air, digest the food inside our stomachs, and improve our immune system. They're crawling on the ground all over the carpet. You start climbing the fleece. On your way, you meet cocci that look like huge potatoes, spirilla similar to spaghetti. After a few hours, you finally reach the top of the carpet. For you, it was a long time, but in reality, just a couple of minutes have passed. The smaller you are, the slower the time's going. Do you remember how difficult it is to swat a fly? That's because it sees your movements in slow motion. So, looking around, you see an endless forest of fleece. In the distance, you can see the silhouette of a big mountain with a flat top. It seems bigger than Everest to you. Great, now you need to get there alive. Suddenly, a huge bacterium attacks you from below. Its several bacilli join together. They look like a bunch of sausages. To escape, you jump down. You weigh so little that falling from any height is safe. You run through the dense forest. You notice that almost all bacteria are going at you. Most of them eat organic material, such as glucose or carbohydrates. And right now, hey, lucky you, you're the biggest source of carbs. Smaller microbes stick to your legs, arms, and face. You shake them off and fall. Several bacilli joined together are approaching, but then a round object with spikes the size of a football crashes into them. You see a lot of these balls and realize they're viruses. Microorganisms that can't live apart from bacteria. To reproduce, they must infect a living being. The viruses have entered the bacterium. Other bacteria that chased you are attacked too. You see a gigantic bacterium that looks like a passenger Boeing without wings. It's a type of cocci, several big balls attached to each other and about to eat you. You see a small prickly football getting inside its body. The bacterium shivers and freezes. After a moment, a hole appears in it, and hundreds of thousands of viruses fly out. They're everywhere and looking for a new host. Prickly balls fly towards you at high speed. You grab a piece of lint and swing it like a baseball bat. You fight off the viruses one by one. Your bat breaks, and you run away. It seems that you're safe now. You're entering a huge field. There's nothing here but bacteria. You realize this is a small spot on the carpet that you accidentally burned a few months ago. There's 1 billion microbes here, and they're multiplying at a tremendous rate. One bacterium increases in size and splits into 2. After a few minutes, these 2 bacteria also grow and divide. Now there are 4 of them. The colony of bacteria grows exponentially. With such rapid reproduction, a single bacterium can create offspring weighing about a ton in 24 hours. After 5 days, the bacteria will be able to fill all the seas and oceans. Fortunately, the speed with which they divide is equal to the speed of their destruction. Dryness, a ray of light, high temperature, humidity, all these phenomena control the population of microbes. Under ideal conditions, the bacteria could take over the whole world. You make your way through a field of microorganisms. Large bacteria consume small ones. They multiply and are being destroyed. It's a boiling sea of life. You feel your foot is stuck. You stepped on something sticky. Right underneath, a large spherical bacterium crawls out of the ground. It's connected with other bacteria and hasn't gotten a certain form. It looks like formless pulsing biomass. The thing is clinging to your body, wrapping you. It feels like you're being absorbed by warm jelly. The bacterium compresses your chest. It's hard to breathe and move. At this moment, something that looks like a metal screw smashes into the bacterium. A large diamond bursts in next. After that, several thin, smooth legs looking like curved needles get inside too. All these details unite and transform into a strange creature inside the microbe. A diamond is attached to one end of the screw, and the needle legs cling down. Several dozen of these break into the jelly's body. They connect together and form an army of robots. All these creatures break out from a small hole in the bacterium and tear the microbe to pieces. You escape and find yourself in chaos. The little robot with a diamond for a head is called a bacteriophage. Despite their appearance, they're created by nature, not artificially. The goal of bacteriophages is to attack and destroy bacteria from within. That's how they reproduce. These creatures are all around us everywhere and control the population of microorganisms. When bacteria multiply inside the human body, they leave waste products of decay. This waste is harmful to the body, so it has to fight. Sometimes doctors use bacteriophages, so they help to get rid of bad microbes. They don't attack anything but bacteria. And now you see hundreds of billions of bacteriophages destroying billions of bacteria. The walking diamonds jump on the bacterium, plunging their heads into it, and release the genetic code, separate parts that assemble in new bacteriophages. You continue on your way and take a few diamonds with you just in case. The road is long, but after a few weeks, you finally manage to reach the puck. In the normal flow of time, it's been an hour. You're exhausted, and there's still a whipping to the top. The puck is so high that you can't see the top of it. You can't sleep because you might wake up inside some microbe. There are still a lot of bacteriophages around, but you don't want to take any chances. A deafening crash shakes the air. It's like an airplane turbine is running right next to your ear. You're looking up. A creature the size of a city lands on the carpet from the sky. It flaps its wings and makes this noise. The wings create a hurricane. You grab the fleece to keep yourself from being blown away. The creature smells bad. One of its legs resembles a large skyscraper. You realize it's a fly. Here's your chance to get to the puck. Big orange eyes divided into thousands of segments look like two planets. You climb on the tip of the fly's leg. The insect takes off and you hold on tight. The carpet is moving further and further away. From up here, you can see the top of the puck. It's so wide that you can't see the round edge. You let go of the fly and fall. In the air, you run into millions of bacteria. Finally, you land on the solid puck surface. The device activates, and you return to your normal size. You are, indeed, one lucky bug.
It's dark, and you can't see anything. There's slime all over. The ground is soft and moving. You try to find your way around by feeling the moving walls around you. After a while, you hear some painful screams in the distance. You call out for help, but no one responds. You're a captain of a ship, and you are just consumed by the mighty Kraken. You keep tumbling over, not knowing if you're even going in the right direction. The screams get louder and louder. It's only a matter of time before you see someone. As you make your next step, a large piece of wood swooshes past you, almost knocking you down. That piece of wood was from the ship that the Kraken had swallowed. It had also swallowed the entire crew alive, so they must be somewhere inside the beast's belly. You keep following the screams. They lead you down another path that looks like an esophagus. You grab a piece of wood and slide down the slimy insides. It's dark, so you rip out a piece of cloth from your shirt and wrap it around a large plank, setting it on fire. This makeshift torch allows you to see where you're going in proper detail. You can see the large veins pumping inside. Each vein can fit more than 3 people through it. After a while, you start seeing more debris from your ship, including the treasures you had discovered and kept in the bottom. But now, those huge piles of gold are worthless since you're out looking for your crewmates in this dark, smelly interior. You reach a point where there seems to be multiple tunnels around, each leading to a different point. You know it's impossible to climb back out from the mouth, so going deeper is the only solution. You decide to go with your gut and slide down the smallest tunnel, which is covered in slime and other liquids. You snuff out your torch and tuck it away to use it again later. You slip through and get stuck for a while. The Kraken is still swimming, but seems to be taking a break and stops. The giant veins and blood vessels slow down, and the flesh tunnel that you're crawling through becomes wider. Before you know it, you are plummeting down the large shaft until you reach a liquid pool. The second you splash in it, you start to feel the acid burning through your clothes. You're in one of the Kraken's stomachs. You take off your shirt and paddle on a plank, rowing yourself across the acidic lake. You can see more broken pieces of your ship scattered around. Out of nowhere, the Kraken springs into action and starts swimming rapidly. You don't have a choice but to hold on to the plank and keep yourself afloat without any acid going into your eyes. You shut them. Now, you're tossed further down the stomach where the digestion is happening. Over here, the acid is even stronger and melts anything that's in it. The smell is atrocious, and you can't find your way to leave. But in the distance, you see some of your crew members stranded in the middle of a small stomach island. You see some sharks still swimming around that haven't been digested yet. There's nothing you can do at the moment but try to get through and make it to your crew members. You get on another piece of wood and row yourself toward them. This time, the stomach acid is melting the wood away. Luckily, someone from your crew tosses you another plank, so you hop onto it and row your way to them. You climb ashore. Everyone is happy to see you. You try to figure out a way out, but the exits are covered in acid. More water seeps in along with plenty of marine animals. The acid levels are rising, and everyone huddles together. After a while, the Kraken swallows a large humpback whale that's thrashing around the acidic water. It's making the Kraken upset, so it starts moving, tossing everyone around. You, along with many others, land on the whale and hold onto it tight. It seems like the Kraken wants to expunge the whale out somehow. The inner walls of the stomach contract until it shrinks enough to let the whale out. You and your crew members are still holding onto the whale, but it's not easy. Finally, the Kraken spits out the whale and swims off to the bottom of the ocean. The new challenge is to swim to the surface to breathe. The whale pushes you and everyone else up. Without it, no one would have made it to the surface to catch some oxygen. You don't know where you are. Some of your crewmates grab onto some loose pieces of your ship to stay afloat. You swim to one and climb aboard. The sun is starting to set. There's nothing in sight. The crew is feeling cold and hungry. Worst of all, it's feeding time for the sharks. Everyone climbs up on their planks to stay out of the water. Before you know it, shark fins start to pop up from every corner. There's nothing to do except survive the night. The next day arrives. No one has managed to get any sleep. Everyone decides to fix all the planks together and row towards the sun. While other people debate another direction, the whole crew listens to your final word. The sun is scorching and everyone's energy is low. There's no fresh water to drink. No one can catch fish for eating. There's still the ever-looming threat of sharks and the Kraken. One of your crew members spots something in the distance, which appears to be an island. Everyone cheers and hugs each other and paddles their way there. After a few hours, you reach the island and stuff your hands in the sand. Someone is running around, while others embrace the sand and palm trees. But for some reason, something seems off. Some birds are flying around. They aren't scared of you. Everyone moves to the center of the island to discover if anyone has been here before. A small campfire sits in the middle of the island, but there are no signs of people anywhere. This island's too small to have any residents. There seems to be no sign of anyone who has ever visited it, besides the campfire. After a while, the island starts moving. Everyone climbs a tree, and water covers the island. In the distance, you see a large figure emerge from the water and turn towards you. It's a giant sea turtle. You were on the back of a giant sea turtle this whole time. It moves gracefully across the water and stops after a couple of hours. The crew members build some huts and start a fire to cook some food and sleep comfortably. You look out in the distance and at the night sky with the stars populating the horizon. You climb the highest tree to get some rest and peace. Far away, you see the kraken swimming around and getting closer to the turtle. But compared to it, the kraken is only the size of a shoe compared to a person. The next day, you tread around and discover the rest of the Turtleback Island. Some unique animals you've never seen before are living here. Some of the most exotic birds are flying around, and the animals don't seem to take you as a threat. You reach the top of the mountain covered with trees and vines to get a good look at the island. You have a panoramic view of everything and discover that there's a huge hole in the ground right below you. And you see what appears to be digging tools left by other explorers. You gather your crew and rush to the hole. You have to make your way through vines and climb over some challenging terrain to reach there. The main question is, where does this hole go if the bottom of this island is a giant turtle shell? You step on the site and see many abandoned tools and plans. You pick up a map and see that there is an X marking for treasures beyond anyone's imagination. You gather your crew. Everyone picks up some of the equipment. Another scary question is, why did they abandon this equipment? You study the plans. They state all the steps except the final one, which no one seems to have figured out. After a while, you descend the hole and make your way towards the bottom. But what you discover is even more shocking than what you expected. And you'll have to find out what it is next time. Is that Earth you can see at a distance? Right. Just look at it, floating in space, hanging out with its planet buddies. You spot orange-red Mars and Jupiter with its asteroid belt. Even tiny Pluto is there. All these planets keep their distance from each other, moving along in their own orbits. They're not very social, you see, but that's a good thing. It would cause nothing but trouble if they started to bump into each other. But even though there are others, Earth is the only planet we know that has life. And we've even figured out why. It's because it was lucky enough to appear in the best spot in our solar system, in the Goldilocks zone. Scientists say the key ingredient for life is water. But, well, there's water on Mercury. This planet has deposits of water ice at its south and north poles, but only because those places never see the light. Everywhere else, water simply evaporates from the surface of the planet. Mercury is way too close to the sun. Pluto has some water too. Astronomers even think the dwarf planet might be up to 30% water, but it's frozen. Unlike Mercury, Pluto's too far away from the sun, which is why all its water is in the form of ice. But Earth hovers in a perfect spot called the habitable zone. It has the right temperature for the water to remain liquid and for all forms of life to flourish. But what if Earth was the only planet in the solar system? No Mars, no Jupiter, no Mercury, no Venus. Things might have turned out a little different than what we're used to. Remember that massive asteroid that hit the Earth around 66 million years ago? Well, without Jupiter and its asteroid belt, our planet would be constantly hit by meteorites and asteroids, and some of them would be just as big as the one that caused all that sorrow to the dinosaurs. These rocky fellas would be roaming around in space with no one and nothing to stop them. And if Earth was the only planet out there, it would also be their only target. But that's not all. Look at all this huge space Earth would have all to itself. It means our planet would have an opportunity to travel a bit. It could even choose to leave the Goldilocks zone. But then, would life on the planet still be the same? So let's say Earth started drifting away from the sun. Then, it'd soon get too cold on the planet. Picture a place where the sun doesn't shine anymore. Dark, cold, covered in ice and snow all year round. That would be our Earth if it traveled further from the sun. If this happened, our cities would start to look very different. Right now, Earth is full of life. Come to any park and you'll see green trees and grass everywhere. There will be people walking, sitting on the benches, enjoying the sun. You'll definitely spot someone playing soccer or frisbee. On the park's lawns, there will be people resting on their blankets, soaking up the sun. A few people will be reading their books, looking relaxed and happy. Back in space, you see Earth again. The planet is still in its favorite spot. That's why life is so beautiful down there. But wait, is it moving? Our planet is definitely further from the sun now. Has it changed things for Earth? It actually looks a bit bluer now. Down there, famous golden California is not so golden anymore. It's gloomy and dark, much like all other places on Earth. New York is covered in ice. Even in the hottest places, the temperatures are now below freezing, including tropical destinations like the Bahamas. After a while, liquid water turns into ice. The oceans now look like giant skating rinks, except there's no one to skate there since the planet has become way too cold to support life. Okay, then what if, instead of drifting further away from the sun, Earth moved closer, with people still aboard? Whoa, the temperatures here are crazy, too hot to handle. The climate would be getting hotter and hotter. Natural disasters would start to occur more often. Hurricanes and floods would be a common thing on Earth now. And pretty soon, the planet would get too hot for people to handle. Particles from the sun would become a serious threat. The atmosphere would be struggling to protect Earth from solar radiation, but this shield would be growing weaker. Liquid water would be nowhere to be found anymore, maybe only in underground deposits. Earth would look a bit like Mars, all rocky and barren. The Mississippi River would dry up and leave behind a huge canyon. All the oceans would be gone too. At the moment, the Mariana Trench is the deepest known place on Earth. It's incredibly hard to reach its bottom because of the immense water pressure there. But without water, trips to the deepest spot on Earth would be possible. It would help people uncover some more of Earth's secrets. If people still lived on the dry and scorching hot planet, that is. In other words, if someone was to explore Earth after the planet had moved closer to the sun, everything would be completely different. But what if Earth didn't move at all and everything remained the same? The only difference, there would be no other planets around us. It would change the way people explore space. Sure, there would still be navigation, communication, and weather satellites, and maybe space telescopes. But there wouldn't be any other space objects close enough for people to send missions there. This would affect the future too. If people had no desire or opportunity to go to space, they would invest in their home planet. They would build sky cities instead of looking for other planets to colonize. These days, if you get a state-of-the-art telescope, you'll see distant stars and other planets. The better the telescope, the more detail there is for you to see. But with no other planets out there, the picture of space wouldn't be so exciting. Stars would still be visible, and you might even spot a meteorite or two. And you'd definitely see the moon, but that's about it. Space agencies would mostly be focused on keeping Earth secure, mainly because asteroids would become frequent visitors. To protect the planet, scientists would have to figure out ways to get rid of them. Like a massive laser beam. When turned on, it could go all the way to the moon and even further. Instead of building rockets to explore space, SpaceX and NASA would be in the asteroid clearing business. People wouldn't even think of trying to contact other civilizations. If there were no planets similar to Earth, they would consider it a wasted effort. This means no radio signals being constantly sent out to space. A curious fact, in February of 2008, The Beatles' song Across the Universe was beamed into deep space. It was done to celebrate both the song's 40th anniversary and NASA's 50th anniversary. In the 70s, people also sent a radio signal out into space. It contained some basic information about humans and the solar system. But it was more a feat of strength for technology than an attempt to contact any alien buddies we might have. With no planets around, the world of sci-fi would change too. There would be no more movies about deep space exploration. No massive spaceships and rockets would appear on the big screen. And since there would be no expeditions to other planets, no rovers would be sent to space to look for signs of life and explore new worlds, like what the rovers on Mars are doing right now. People would concentrate more on their own planet. For example, they would begin to explore its insides. New technologies would allow us to dig much, much deeper, all the way through Earth's crust and further. And doesn't a trip to the planet's core sound exciting? Instead of astronauts, there would be explorers of the deep underground. New drilling technologies would be invented to make the digging process more effective. There would be new types of vehicles. They would be created to drill and protect explorers from the enormous underground pressure. While exploring the world under the planet's surface, people would likely find absolutely new life forms. Those would be mysterious creatures that evolved to survive in the dark, in extreme temperatures, and with barely any food. It certainly helped people understand more about their home planet. You're sitting in a car in a space shopping mall parking lot. You've just bought a gift for your sister's birthday and should have time to get it to the celebration. Today, there are a lot of people in the mall, so it's difficult to leave the parking lot. Finally, you're approaching the gate. You press the button next to the steering wheel and activate the gravity cushion. It allows the car to hover above the ground at several inches. The car wheels are sliding inside the body, and a huge turbine is coming out of the trunk. The front glass becomes a touch panel with many buttons and screens. The gate opens, the turbine releases a flame, and your car flies out of the parking lot, right into outer space. Thousands of flying cars are rushing past you on an invisible space highway. You're moving away from the mall, which looks like a huge space station surrounded by holograms of advertising brands. Before Earth, you need to get to Mars. There, you want to repair the car's engine. The navigator plans a route to the red planet, and you go on your way. You're far from Earth's orbit, so you can get to Mars in several hours. You activate the autopilot and decide to take a little nap. It's 2048. The world's population has exceeded 20 billion people. There's too little space on Earth. Humanity is not ready to colonize other planets yet. So scientists and engineers from all countries start building huge space stations. This unloads the planet by more than 50%. The stations look like huge rings. They imitate the Earth's atmosphere, have artificial gravity and vegetation. People move to stations, but often return to Earth. Rockets fly between the planet and orbit, but such transport is expensive and inconvenient. Automakers make efforts at creating super reactive flying cars. Some years later, people slowly colonize the Moon and Mars. Now, getting to the red planet is as easy as getting to the neighboring city. Cars fly along certain routes that are similar to airways for planes. Engineers create special digital highways that can only be seen through the windshield. Of course, you can fly through space as you like, in any direction. But if you fly to a mall or the moon, you have to stick to the established digital route. You wake up and approach Mars. People almost don't live here because of the unfavorable atmosphere and difficult weather conditions. But Mars has the biggest service center for cars and the coolest amusement theme park in the solar system. To get there, people have to stand in a space traffic jam for hours. The dashboard shows you have some problems with the turbine. You put on a spacesuit, take a laser screwdriver, and get out of the car. You're in zero gravity, flying up to the turbine and fixing the problem with the screwdriver. There are thousands of cars around you. People are yawning inside, listening to music, and watching movies. You get into the vehicle and slowly move on. The engine or turbine often fails in the middle of a space highway. When this happens, your car activates its emergency mode. The dashboard automatically sends a signal to the nearest repair team. You're just floating in space and waiting until the mechanics arrive. They tow the car to the nearest auto service. You have enough oxygen inside for a couple of days, and if you run out of it, you can ask for help on the internet. Good people flying by will stop and share their oxygen supplies with you. Finally, you get to the car service station. Mechanics install a new super jet engine for your car and repair the turbine. There's not much time left, and you promised your sister you wouldn't be late. You get into the car and leave the Martian orbit at full speed. The new engine runs silently and doesn't shake the car. You increase the speed and fly along an almost empty digital highway. On your way, you meet a lot of small satellites showing holographic ads. Fortunately, you have an ad blocker. You turn it on, and the space banners become invisible through your windshield. Finally, you see a small blue dot. This is Earth. At this moment, you remember that you need to feed your dog. You leave the route and fly to the moon. There you have a small cottage with a house, which you bought for a small price last year. People can't change the atmosphere of entire planets yet, but you can install a small dome and fill it with oxygen. Inside your dome, you've built a house, a swimming pool, and even a small vegetable garden. In the past, people went to the countryside to take a break from the city bustle. Now, everyone just buys houses on the moon. You fly through the dome, land on the white surface, and put food into a dog bowl. They're renovating your apartment on the space ring, so you live on the moon with your dog for a while. You can see other cars flying up into the neighboring domes. Some vehicles are elite supercars with a large gravity cushion and ultra-reactive engines. They can fly 10 times faster than the speed of sound and have artificial intelligence that can talk to the driver. There are also old, rusty space cars. Sometimes people attach a jet engine to an ordinary car and cover the body with a mix of copper, iron, and silver to travel over long distances in a cold vacuum. You can also see a lot of taxis in outer space. Sometimes, getting to the moon is cheaper than getting to the other end of some city on Earth. The reason is traffic jams on the Earth's roads. Also, there are a lot of flying buses in space. Every day, several flights depart on the Earth to Moon to Mars route. People are constantly building something on Mars. The huge car service and the amusement park are done. Now they're creating a scientific center there to study interstellar jumps. Of course, engineers need building materials for such construction projects. Several times a week, long trains fly from Earth to Mars along a separate space route. Initially, trains carried people, but they became unprofitable. It's much cheaper and faster to get to Mars by your own car or bus. Finally, you're leaving the moon and approaching the Earth. The dashboard signals you're out of fuel, so you decide to stop at a gas station. These stations are everywhere. They're fully automated, controlled by artificial intelligence. You're flying up to one of them. The fuel pump is automatically connected to your gas tank. The super-reactive engine consumes improved rocket fuel instead of gas. You transfer money to the station through the touch panel and fly away. Hundreds of digital space highways lead to Earth, and every road is filled with cars. Traffic jams again. There are security checkpoints in the upper layers of the atmosphere. Customs services check documents and car trunks. While standing in traffic, you're watching garbage trucks. A lot of space debris is floating around. Slow-flying trucks controlled by artificial intelligence collect garbage in huge containers. Then, they fly away from Earth's orbit and unhook the containers. These garbage cans have little turbines that let containers fly far beyond our solar system. Then, they heat up and burn all the garbage from the inside. Finally, you pass all the checkpoints and fly into the middle layers of the atmosphere. Our planet looks like a huge cyberpunk world, but only lighter and more beautiful. Huge cars disperse the clouds to improve visibility. Firefighter flying ships are coming to one of the stations where a fire started. You encounter hundreds of gas stations, air hotels, cinemas, and shopping malls in the sky before you reach the ground. You're approaching a parking building. This is an 80-story skyscraper filled with cars. People leave their vehicles and use elevators to go down. Fortunately, there's a place near your sister's house where you can park your car. You land, put your hand on the passenger seat to take the gift, and oh no! It looks like you left it on the moon.
You wake up with pizza boxes piled up on top of each other. You stretch your right arm and slide it across some wet spilled noodles you had last night. Your leg smears some chocolate cake from last week and stains your mattress. There are random papers, clothes, books, food cartons with food still inside them, and other random useless junk all over your queen-size bed. You're too lazy to get out of bed, but you have to get to work. You shove aside all the junk and slide it onto the already littered ground. There are plastic bottles, more fast food litter, clothes, dirty dishes, and animal fur on the ground. It's sticky and covers every inch of real estate to the point that you feel like you're walking on lava. You stare out the dirty window, look at yourself in the mirror, and sulk. This isn't the you you'd thought you'd be a year ago. The sun is shining and you just bought your brand new house. It's a nice place outside the city in a little friendly neighborhood surrounded by picket fences and blooming flowers. Your neighbors come up to greet you just as you pull in the driveway. They bring a casserole and some yummy desserts to welcome you to the neighborhood. You gleefully accept them and head inside your new pad. Throughout the week, you unpack your bags and arrange your furniture. You also just landed a new job which helped you afford this house. You wake up every day at 6 a.m. and come back home at 10 p.m. This new job is paying you well, but you don't have time for yourself or to keep your house in order. Over the next few months, you start ordering food every night and bringing leftovers to work. You haven't changed your bedsheet since you arrived and haven't vacuumed the floor since you first stepped foot inside. The smell inside is getting stronger, considering you're not taking out the trash or opening the windows to air out the house. You've also given up on sorting out your dirty laundry. You have no more clean clothes left, so you're reusing the same clothes for work, but they have food stains all over them. The bathrooms are not a place anyone would like to go. The running water drips and overflows onto the floor, making it damp inside. Since no sunlight enters, mold grows abundantly, providing a home for various bacteria and parasites. It's no wonder you call in sick every month. So much work has made you lose sight of your house and has affected your performance at work. You've gotten multiple warnings and have been told to take care of yourself and get new clothes or wash the ones you have. But the more clothes you buy, the more dirty stacks of clothes appear all over your house. There's no place to sleep anymore. Your bed is a mountain of junk, and your couch is home to boxes you haven't even unpacked since you moved in. You order a sleeping bag and crash in the dirty kitchen. Cockroaches are crawling on every inch of the kitchen floor, counter, and little crawl spaces. Rats have chewed on most of the wooden furniture and created a network of underground tunnels for them to access every area of your house. You hear the little rat tails clacking on the tiles whenever they run past your ear. You try to sleep, but the dishes in the sink are so stacked up that the dripping faucet channels water to run through the plates and glasses and splash on your forehead. You pick up your sleeping bag and place it in the basement. The smell is unbearable. There is moss growing in every corner and even a small puddle of stagnant water festering and providing a home for mosquitoes, bacteria, and other vermin. The rats and mice use this small pool as a swimming ground to have pool parties and clean themselves up after a long day of eating your food and creating tunnels. There are thousands of rats in every corner, but you somehow don't mind them anymore. You see little nests of baby rats in the dark corners. The wooden foundation is failing and being eaten away by termites and the buildup of mold. You wake the next day with rat footprints all over your body and go to work only to be kicked out and sent back home to clean yourself up. You try to shower, but the pipes are clogged and only a few drops of dirty water land on your body. You go to the backyard that has a dirt-filled patch where you were supposed to build a swimming pool, but didn't have time to follow up on it. You lay your sleeping bag on the dirt and try to find a garden hose to clean yourself. But rats have gnawed through the plastic, so it can't spray properly. Either way, you rinse yourself with water and try to dry yourself with some garbage bags, since you can't find your towels in the sea of trash. You go back inside to watch TV, which surprisingly still works. You clear some space on your couch and order pizza. You have a stack of pizza boxes stacked on top of each other, forming a makeshift coffee table, and you rest your legs on it. The pressure and weight of your legs allows some insects to scurry away that have been eating the leftover crusts and cheese. The doorbell rings and you get up and answer it. The delivery guy is already in his car driving away from the stench. They all know you by now. It's a good thing you paid online. You go back to watching the movie while seeing some more critters crawling all over your TV set. Hours pass, and you realize that you need to wake up early for work. You make some room to sleep, but scratch your head on some sharp object lying around the couch. Months pass. The neighbors stop talking to you, and even straight up ignore you. They avoid you every time you leave your house. Mostly, they gossip and comment on your house. All the pests that came from your house are spreading throughout the neighborhood. Pest control cars are driving in and out of the neighborhood, visiting a new house every day. Flies and maggots have settled your house to the point that it's impossible to walk around and not have some flies circling your face. Anyone who drives by the neighborhood knows that your house is the source of the infestation. Many more months pass, and your house is unrecognizable. It's impossible to see the floor, and the walls have scratches all over them. Rats have taken over and nibbled on just about everything. They've become your new friends when eating and even finish some leftovers for you. The basement is completely flooded, and the water is leaking out to the main road. Other creatures have sought shelter in your home, including stray cats and dogs, raccoons, possums, and even bats. You have broken glass all over the floor from the busted light bulbs, and your mattress has holes all over it. You wake up with pizza boxes stacked all over you, and then look at the mirror. It's your 1-year anniversary of moving in, and this isn't the life you imagined. Out the window, you see your neighbors selling their homes, with some already gone, including the one who welcomed you when you first moved in. You turn around and, as if for the first time, you finally see that your house is such a mess. You spot a picture of yourself hanging on the wall. You put it there when you first moved in. You decide to fix your house and clean it all up. You know it'll take weeks or months, but you skip work and begin by cleaning up your room. You get boxes of garbage bags and start stuffing trash inside. You buy 3 new vacuum cleaners and start collecting all the dust and debris that has collected over the past year. After a couple of hours, you have over 20 garbage bags outside your house waiting to be collected. The stains will need to be scrubbed away, and the destroyed furniture will need to be thrown out. After 2 months of hard work, you manage to get rid of all the trash you can find. It takes you another week to scrub the floors and walls and order new furniture to replace the broken, chewed-up ones. The biggest challenge is getting rid of the remaining pests and fixing the basement water problem. After making some phone calls, you get some pros to fix the water and get rid of the vermin. It takes you a total of 4 months to turn your place into a minty fresh pad to live in. Your garden is blooming, and you go back to work in fresh clothes with a wide smile. And you get to meet your new neighbors, who have heard all about you. Yep, you have some fences to mend, don't you? So, another crazy thing happened to me recently. It was a Sunday morning, and I fried eggs for breakfast. But something was definitely wrong. I wasn't sure if it was the eggs or me, though. Now, you've tried fried eggs, right? They normally taste like, eggs. But that time, along with the eggs, I could also taste lemon, vanilla yogurt, and even some paper. And it's not as good as you might think. Yogurt tastes nice by itself, but together with eggs, it's gross. Whatever was the reason, I decided I'd be okay with just a tea for that day. But as soon as I tried it, I spat it out. What is that? Did I put a spoonful of black pepper there? I needed some water ASAP. I got a glass and, thankfully, it was just a regular glass of water. I tried to eat some strawberries, but along with the normal strawberry taste, they had a taste of hot chili. That's not a good combination, to be honest. It looked like something happened to all of the food in the house. I also had an orange juice, so I drank a glass of it. Surprisingly, it tasted totally fine. Suddenly, I got a weird thought. Do I taste colors? It was so crazy and strange that I needed to check this theory immediately. I admit I licked the white back of my cell phone, but it really did taste like vanilla yogurt, just like the egg. So, it was true. I could taste colors that would mix with every food's original taste and mess it up. I wanted to go to the doctor, but although this new superpower was weird, it was still a bit exciting. Also, I couldn't wait to figure out what other tastes are like. So, I went to a store and got myself a pack of markers. I got to the table, opened the yellow one, and licked it. It did taste like lemon. So, I licked each one and made a list. Pink tasted like strawberry. Red was chili. Orange was an orange. Blue was very bitter. Light blue was salty. And violet was blueberry. Black was black pepper. Beige, nut muss. Gray, paper. And green tasted like puke. Well, I had to conclude I don't eat green food from now on. Not that I was really sad about it, though. Only one color was left, the brown one. I was very reluctant to try it, but I had to figure it out. Whew. To my relief, it had the taste of coffee. Now, I don't like coffee, but it could be worse. I knew I had to go see my doctor, but I kind of wanted to live with this superpower for a while. It doesn't happen to you every day, So I decided I'll go to the doctor tomorrow. And today, I had to learn how to live with this ability. I had to avoid putting in my mouth anything black, gray, blue, and green. Not only food, but the dishes and cutlery as well. And I had to figure out what food I can actually eat, because I didn't like strawberries that tasted like chili pepper. So I went to the store to get some transparent dishes. While walking, I was thinking about my menu for today. Orange juice works, strawberry, vanilla, and lemon yogurt too. I can make a fruit salad with mango, raspberries, grapes, banana, and yogurt. But that was all I could come up with. As I was thinking, I was biting my lip and found out it tasted like strawberry. In the store, it was pretty easy to find a transparent bowl, but spoons and forks were a problem. I think I went to every store in my city until I could finally find them. As soon as I got back home, I cut all the fruits and made a fruit salad. I hadn't eaten much that morning, as you remember. Honestly, it was the best salad ever. I saved some money because I didn't have to buy berries, oranges, and lemons, but the taste was there. As I was enjoying my meal, the phone rang. It was my grandma, and she invited me for dinner that evening. I tried to say I couldn't make it, but she wouldn't listen. Grandmas. It's just impossible to skip when they want to feed you. So she said she didn't want to hear any excuses and that I had to be at her house by 6. This meant I couldn't wait until tomorrow. I had to go to the doctor right then and get rid of this superpower before my grandma made me eat puke and drink tea with black pepper. I checked the time. I had only 20 minutes before my doctor left, and the clinic was several blocks away. I finished my salad and ran out of the apartment. I got to the clinic just 5 minutes before it closed for the day and asked if my doctor could see me because I had an emergency. To my relief, he agreed. When I told him that I could taste colors, he looked at me puzzled and probably thought it was a stupid prank. Then I told him the whole story. about the fried egg for breakfast and how I bought and tasted all the markers, that violet was blueberry and green was not an apple as he might have thought, that I spent hours trying to find a transparent spoon and fork. To be honest, in my head it sounded better and was making much more sense. The doctor was silent and kinda suspicious. He measured my temperature, my blood pressure, and looked at my mouth. "So, you've been eating markers," he smiled. Oops, I guess my tongue was the color of a rainbow. Well, that really doesn't sound normal for a grown-up. The doctor obviously didn't believe me, so he just let me go, recommending a good night's sleep. So, I guess I was stuck with it, and I had to go to Grandma's. Unfortunately, there was no way she'd feed me strawberry yogurt for dinner. I got home to get my new cutlery, so at least I didn't have to taste paper when eating with my grandma's gray metal fork. I had another couple of hours, so I did some Googling, but still couldn't find any solution or even research on my condition. I thought that maybe I could wash it off, so I drank a gallon of water. But it didn't help, so I went to Grandma's place feeling doomed. Plus, I really needed to go. She was happy to see me and announced that she had my favorite broccoli pancakes for me. Yeah, maybe yesterday they had been my favorite, but definitely not anymore. I tried to say I'm not hungry and I could just drink some orange juice, but of course, she wouldn't listen. She gave me a plate with 5 pancakes and a cup of black tea. Suddenly, I got an idea of how I could get rid of at least the pepper taste. If I put a piece of lemon in the tea, I'll get brown. Therefore, I'll have a coffee tea instead of a pepper tea. I was lucky. My grandma did have the lemon, so the tea problem was solved. But the worst part was the pancakes, and my grandma was looking at me all excited and pleased. I had to eat. I was trying hard to control my facial expression and look very happy, as if I was eating the best food on the planet, even though it was the most terrible meal in my life. And yes, I was drinking a lot of my coffee tea. Well, 3 cups. But when I finished and thanked my grandma, she was so happy that I understood eating puke was worth it. Turned out my grandma actually had a vanilla yogurt, so I ate all she had to get rid of the taste I still had in my mouth after the pancakes. On my way home, biting my strawberry lip, I was thinking, I had to come up with a plan on how to get rid of this ability. But I couldn't think of anything. So as soon as I got home, I just went to sleep, even though it was only 9 p.m. I slept for 11 hours, and the next morning, I made myself a fruit salad with yogurt. Again. I guess from then on, it was my dish for the rest of my life. I was eating it with my transparent fork and watching a TV show, when I suddenly realized I couldn't taste any lemon there, and no orange as well. I bit my lip and it didn't have a taste anymore. With my hand shaking, I opened the fridge to get my strawberries. I ate one and it tasted like a regular normal strawberry. No chili pepper. Everything was back to normal like it never happened. But I swear it did. Really? Hey, if I said, "What time is it?" you'd probably look at your phone, laptop screen, or wristwatch to find out. But how do these devices know the time? In your devices, the time is set automatically by the program. But how does this program know the exact time? People set up wristwatches before the sale. But then, how do these people know the time? Does anybody really know what time it is? Hey, there's a song there. Anyway, how do we determine this time? And what happens if all the clocks in the world stop? Wait a minute. Or longer. So, welcome to the National Physical Laboratory in southwest London. Here you can find some of the world's most famous atomic clocks called hydrogen masers. There are about 400 such devices around the world, and they help the whole planet navigate through time. All modern technologies, satellites, operating systems, GPS, flight and train schedules, and the TV program on your screen are guided by the atomic clock. And here's how they work. Imagine a pendulum. It swings from one side to the other. One swing from left to right, or vice versa, is a period of time equal to 1 second. The pendulum is not very accurate since it's not constant. Its movement may slow down or accelerate. In atomic clocks, atoms do the function of a pendulum. When they're exposed to microwave radiation, they begin to fluctuate. About 9 billion fluctuations are equal to 1 second. Don't believe me? Hey, count them yourself. The vibrations of atoms are precise and unchangeable. These clocks are not lagging behind and not accelerating. The error in such a clock can be 1 second once every 10 million years. Now, I can't wait around that long, so I'll take my word for it. Atomic clocks guide all modern technologies and communication satellites. And now, let's imagine that, for some reason, they stop working. Atoms no longer react to microwaves. After them, quartz watches and all electronic ones stop. Your phone no longer shows the time, and the arrival times of flights disappears on the information board at the airport. At this moment, all dispatchers contact the pilots and ask them to land urgently at the nearest airports. Further flights become impossible. There are too many planes in the sky. If several start taking off and landing at once at the same airport, it can lead to a disaster. Dispatchers wouldn't create the correct schedule without clocks. The same goes for all trains. Train stations can no longer coordinate trips and make switches on railway tracks. This system is too complex and can only work with a precise time. The world is beginning to plunge into complete chaos. The banking system is collapsing. Brokers don't transfer money to clients' accounts on time. People can't get their salaries on schedule. Imagine you promise to send a presentation to a client tomorrow at 2 p.m. and expect to get paid for it. The next day, you don't know what time it is, and send the presentation to the client 2 hours later. They don't get the file on time, and the deal falls apart. At large plants and factories, the schedule of the day gets down. People don't give out the necessary volume of production. Imagine some factory produces 2 tons of processed steel in exactly 8 hours. But the rhythm of work is disrupted, and this reduces the volume. Next, the steel should go to the ship. However, the ship schedules are no longer working either. And this applies to all materials in general: wood, electrical carriers, oil, and metals. Logistic chains collapse because of the stopping of the clock. There's an economic crisis and panic in the world. The exchange closes and opens every day at different times. Shareholders and investors are losing a lot of money. Some say that the clock, not the steam engine, was the most important mechanism for the Industrial Revolution. Steam engines powered cars and ships, but they couldn't synchronize the work of many people. Under such conditions, you stop rushing anywhere, but so do all the other people. You can come to the supermarket, and it will be closed because its owner overslept. But then, when its doors open, you'll find that there are almost no goods there. Ships, trains, and trucks couldn't deliver fruits, breads, and vegetables because they couldn't agree on the time. Many will leave big cities, as it'll be challenging to live there without clocks. The age of high technology has ended. TV channels stopped working because some employees were late and didn't start the broadcast. The channel host came before the operator, but the sound engineer is still sleeping because the alarm clock doesn't know what time it is. To stop the chaos, 2 things need to be done. The first is to accept that the former high-tech life will no longer exist. The second thing is to take an example from our ancestors. People live for thousands of years without knowing the exact time. It has been necessary only since the beginning of the Industrial Revolution. Before that, people were guided by the sun, the rooster singing, and the internal biological clock. For hundreds of thousands of years, humans used to go to bed at night and wake up in the morning. But with the invention of the light bulb, this order was violated. The industrial era forced humanity to focus not on the internal clock, but on the opening time of factories and plants. Then TV, the internet, and video games were invented, and the sleep mode established by evolution changed. But in a world without counting time, people will forget about alarm clocks again, and start improving their sleep. There will be a sundial in every house. The shadow will guide humanity. Hourglasses of various shapes and sizes will be popular again in the world. Sooner or later, we will have returned to some landmark in time as it was in the past. For example, in the 19th century, people used hundreds of different time standards. Railway schedules and buses determined each of them. When the number of routes increased, people started sticking to the same time that was set in Greenwich, UK. There was a big mechanical clock that guided the whole country. Greenwich Mean Time, or GMT. Merchants, factory directors, and bankers adjusted their watches according to GMT. When all UK trains were timed, the GMT signal was sent across the Atlantic via an underwater cable straight to Harvard in Massachusetts. Then, at a special conference in Washington, D.C., more than 25 countries recognized Greenwich as the international time standard. Everything was fine. The technology worked synchronously worldwide, but the problem started. After 10 years, scientists realized that the world needed new clocks. It turned out that the Greenwich clock was inaccurate because it was based on the time our planet spent to make one spin around its axis. In the 20th century, people learned that Earth changed its rotation speed over the years. Oh yeah? It accelerates or slows down because of the gravitational influence of the Moon, the Sun, and other planets, and because of geological fluctuations inside the Earth's core. Scientists calculated that in 1900, the Earth rotated 4 milliseconds slower than at the end of the 21st century. Yes, there are people who watch this kind of stuff. Therefore, people began to develop other, more accurate clocks, atomic ones that we still use. But the strangest thing is that even these clocks don't work in the way people need. Their main problem is excessive accuracy. Earth doesn't constantly rotate the same way, so workers sometimes add additional seconds to the atomic clock or subtract them. And here's why. Ordinary clocks are based on the rotation of our planet. When the time on such a clock shows morning, it's also morning outside. When the clock shows the late hour, it's dark outside. You with me? Our planet doesn't rotate at a constant speed, and the atomic clock is perfectly stable. If the world always worked based on these clocks, then time would sooner or later deviate from the actual day and night. At some point, the sun would begin to rise at 6 p.m., and sunset would start by 7 a.m. To prevent this, timekeepers changed the time on atomic clocks slightly. All of this is necessary to preserve the usual things for people so that the morning hour on the clock and the street coincide. Well, it's time for me to make like an atom and split. You wake up, gasping for air, struggling to peel yourself from your bed. When you do manage to get your feet on the ground, it feels like they're glued down tight. You're twice as heavy. It feels like you're carrying another you on your shoulders all day long. Well, congratulations. You've woken up on an Earth where uncontrolled experiments with dark matter have doubled the force of gravity. Mass panic happens when over 8,000 aircraft fall as soon as the gravity spikes, crashing into buildings, forests, and oceans. And that's because airplanes suddenly lost the balance between the pull of gravity and the lift force necessary to keep them cruising. Pilots did attempt to save their planes, but GPS failed as satellites swiftly moved. After a month, humans begin to look more and more like chimps. Bones are getting thicker, and the immense force constantly pulling people down is squashing their spines, making everybody bend over. People start figuring out that walking ape-style on all fours helps with better balance and stability. And that becomes a big deal, since even tripping over a tiny rock could lead to a nasty fracture. Falls not only get more intense due to the extra forces on bones and joints, but they also happen faster. Gravity's pull doubles the acceleration force, increasing it from 32 feet per second to 64 feet per second. Your house is not a safe place anymore. Old buildings and bridges all over the world are now collapsing. Inside those still standing, residents get the scary feeling that the whole place is shaking, and cracks start showing up everywhere. It's dangerous to stay inside houses, as roofs are now twice their usual weight, and any rain or snow also feels twice as heavy. Car alarms are constantly going off because tree branches keep falling all over the place. Most trees simply can't bear the weight of gravity, and only strong and small plants survive, like cactuses and succulents. 6 months after the sudden change, supermarkets have a sinister vibe going on, with shelves nearly empty and people arguing over the last loaf of bread. You get frustrated to see that your favorite Japanese restaurant is now 5 times more expensive. And it's not just about salmon prices. It's rice that has become a rare luxury item, since the gravity boost has messed up the photosynthesis process, and the seeds are taking too long to grow. On the flip side, carrots are now cheaper than ever. They're sprouting and growing at lightning speed. People start eating so many carrots that human skin now has an orange glow from all that extra beta-carotene. Farmers are getting creative, using artificial supports to keep plants like tomatoes and corn on their feet. But even with all their efforts, it's hard to get a good harvest. Summer has arrived, and even your air conditioner can't relieve the unbearable heat. A sudden change in gravity disrupted Earth's orbit around the Sun, pushing it into a new, tighter elliptical path. Earth now passes much closer to the Sun than it used to, making your sunscreen simply surrender. The Moon's orbit has also had some dramatic changes, leading to more dangerous and extreme tide patterns. High tides are now higher and low tides are lower. This shift has also triggered widespread volcanic eruptions and earthquakes on an unprecedented scale. Earth's crust starts to rupture across vast areas, unleashing planet-wide lava flows so intense that living on Venus begins to sound like a pretty good idea. 5 years later, people notice that puppies are begging for food twice as much, but they are taking more time to grow. Breeds like beagles look thinner and their leg bones are getting heavier. Even insects, such as locusts, now have thicker hind legs to keep those jumps going. Sea creatures are being crushed by the much greater weight of the water around them. That's not a big deal for animals used to deep ocean pressures, like the anglerfish, but crabs and lobsters are really struggling since they live in shallow waters. Sloths and monkeys develop a stronger grip so they won't fall off trees. For carnivorous animals living in jungles or savannas, life is a real challenge because any animal the size of a wolf or bigger can't run without breaking a leg. Large predators like lionesses are starving because they can't move fast enough to catch their prey. Tall trees like palms and pines also go through evolutionary changes. They get beefier trunks and only grow about half as tall as usual. This way, water and nutrients can travel from the ground up to their leaves without struggling against gravity so badly. 10 years have passed since gravity increased. Airlines have finally made changes to prevent commercial flights from nosediving. The wings of airplanes are now longer. Pilots have learned to fly at altitudes twice as high, and flight speed has increased by 41%. To avoid people getting extremely nauseated and dizzy during takeoffs and landings, seats are now fully horizontal, like first-class bed-like setups, specially designed to minimize the nasty effects of gravity times 2. Flight attendants are trained to raise the seat at the passenger's feet after they pass out, so that blood can return to their head. The thing is, when gravity gets a power boost, it yanks your blood down to your feet and hands even more than usual, making your heart work extra hard to pump that blood around, especially to your head. 50 years have passed. Women in their 30s look like they are 60. Higher gravity decreases collagen synthesis, so even though they're still young, they're dealing with more wrinkles and fine lines, and their skin has already lost a big part of its elasticity. Wounds as small as a pimple pop or a paper cut also take much more time to heal. So people are excited about the creation of a Band-Aid made from fish skin from cod or tilapia that promotes local blood circulation and speeds up the healing process. People have also got used to wear exoskeletons made of titanium, which support and enhance the wearer's strength. This technology features cool joints at the places that copy humans' natural movements, giving people more flexibility and letting them move around more easily. Prototypes of personal flying devices start popping up after 100 years. The Gray Flyer is like a jetpack made of carbon nanotubes, making the structure strong without adding much weight. Instead of using fuel for propulsion, the device has these super thin but high-tech solar panels. Investors are still not sure if humans could fly long distances with it, but the Gray Flyer definitely can help people tackle tasks that have become almost impossible, like climbing a mountain or grabbing something from the attic. Things at the gym are pretty different too. The anti-gravity treadmill is a favorite among fitness enthusiasts because it uses air pressure to lift users, reducing the discomfort of gravity while running. People can also lift weights in booths when the gravity settings are customized. When training with G-force set at 3 or 4 times the new normal, muscles get stronger, making double gravity seem more bearable. However, the maximum set is 4.6, otherwise bones might crack. Over 500 years have passed. Thanks to these amazing technological creations, humans can now handle and establish colonies in other parts of the universe. A popular choice for family vacations is Kepler 452b, a planet about 60% larger than Earth, orbiting in the habitable zone of a sun-like star. Kids especially like that place, as oceans have been discovered and hotels have been built near rocky beaches. On the other hand, traveling to places in the universe with lighter gravity is like going to an oasis of tranquility. So Mars and the Moon have become known for amazing yoga retreats. With their gravitational forces much weaker, people can breathe more easily there and move around with more freedom. Keep in mind that these trips are expensive, so you might want to start saving up now.
Around 3 to 200 million years ago, all the continents were stuck together as one big landmass. Over time, they moved apart and formed the continents we have today. That giant landmass was called Pangaea, and the Earth looked very different back then. Which begs the question, what would our life be like if that split never occurred? Well, let's find out. In simple words, tectonic plates are big chunks of the Earth's outer shell. Our planet is like a puzzle of landmass, and these plates are the pieces. Since the Earth is so incredibly hot inside, its heat influences the rocky ground above the core. Slightly melted rocks start floating in the ocean of scorched magma. This movement creates the tectonic plates, and they're always moving, just really slowly, which is why we don't notice it. Their movement has been a fundamental force shaping the Earth's surface, climate, and the evolution of life over millions of years. For example, when two plates bump into each other, one might go under the other. Or they might slide past each other. Sometimes they pull apart. All these movements create things like earthquakes and volcanoes. And when plates push against each other, it can make the land go up, creating mountains. So, the big mountain ranges on Earth, like the Himalayas, formed because tectonic plates were pushing into each other. Now, here's the thing with Pangaea. In a supercontinent, all tectonic plates are united, and they don't really move. Well, at least not a lot like they do now. So if Pangaea remained intact for billions of years, everything in our world would look completely different. For example, we wouldn't have many mountain ranges anymore. No Alps, Himalayas, and Andes. What a nightmare that would be for ski lovers. But there's an upside to that too. No continental drift means much less disasters in our world. All our earthquakes, tsunamis, and volcanic eruptions would be much rarer and calmer, or might not occur at all. However, hurricanes would keep existing, and they could be crazy strong. With Pangaea being one huge lump of land, the rest of the world will be water stretching from the west to east. That's just a free water slide for a hurricane. Please feel free to build up in intensity without anything to bump into. So once it finally reaches us, prepare for Category 5 or even stronger hurricanes or tornadoes. They'd be regular visitors too. And if you decided to live in eastern Pangaea, yep, you're doomed. The way the continents are arranged also affects how the oceans move and the weather behaves. In Pangaea, the climate would be very different across the globe. The middle of our supercontinent would be super weird. Right in the center, we'd have a huge dry desert. But there would also be dense, cool rainforests along the borders of this desert. Why? Because Pangaea is so massive and rain from the ocean wouldn't reach far enough inland, so it would be stacking up around the edge. This would make some parts of the land not so great for anything. Rain and water would wear down the land, flattening hills and carrying away soil over a long time. Eventually, Pangaea might even shrink and disappear underwater. Closer to the edges of Pangaea, the weather might be more mild or tropical. Up north, it would be warmer than it is now. And finally, we'd have some understanding of seasons, but we'd have no idea that it becomes harder for you to breathe as you go higher. So, how would all this affect living things? Well, bad. Pangaea would be awful for the variety of life on Earth. History shows that having separate pieces of land is very important for life. It was a big reason why new kinds of species appeared. For example, Madagascar, an island that broke off from Pangaea, was isolated for millions of years, which is why it has many plants and animals not found anywhere else. Fewer isolated lands like Madagascar and Australia mean less cool and unique plants and animals. The climate problem doesn't go away either. Almost all Pangaea would be hot and dry inside, but it wouldn't be all too boring. There would still be some environments for animals to live in. Reptiles like dinosaurs might do well in this kind of climate. That's one reason why dinosaurs thrived when the whole world was one big landmass before mammals came around. Also, this might push for the development of creatures that can live in water. They'd be more diverse and bigger in size. So basically, Pangaea is a master of creating Earth as dangerous for humans as possible. With all this in mind, let's finally see how humanity's doing, assuming that we survived and evolved. First of all, where would your country be located? In theory, you could take a road trip from Brazil to Canada, because they'd be part of the same huge landmass. North America would be right here, and Europe would be just east of it. Most of Asia would be up north, and Antarctica would stay down south. Australia would still be in the middle of nowhere. A literal Antarctica would be closer to everyone than Australia. That's assuming that countries stayed the same. And hey, cool news! All our modern countries might not exist at all. Okay, that didn't sound as good as intended. More precisely, the countries would have completely different boundaries, and the world would be much more peaceful and united. Let's see. First, we'd form some tribes. But since we would share the land, we'd have to compromise. We can't all have the only coast or only inland regions. Each tribe would probably get a fair piece of the land so that everyone could meet in the middle to settle problems or make trade agreements. As tribes got bigger, people would move to new lands, separated by deserts and forests, forming their own nations. The hunter-gatherer era might take some more time, since we have fewer animals and plants. If we started hunting, we'd probably wipe out all the big animals pretty quickly, except for the ones we could potentially domesticate. Imagine having dinosaurs as pets! But the whole supercontinent would quickly enter the agricultural era, because whatever technologies we discover, we'd share them with each other right away. The main difference would be that during our age of exploration, there would be mostly small, isolated islands to discover. Travel and trade would be easier too. Cultures would be less distant from each other compared to our world. For example, right now, Native American culture is very different from Pacific Island culture because they've been separated by water for a long time. But on Pangaea, cultures might form a continuous line from the southern tip to the northern tip, which means all cultures would be very closely related. And that wouldn't be the only similarity. Our appearances would be very much alike as well. Since Earth is still tilted on its axis, the very north and south will stay cooler. So even though some people would still have white skin and blonde hair, in general, everyone would still have less melanin. Around the central part where the sun is always shining, most people will still have dark or tanned skin. This could create a more similar world where people could see themselves as global citizens and Earthlings. The sad part is, we probably wouldn't be as motivated for technological progress as we are now. All the land is already known. There's no need to explore. The weather is mostly good and warm. The crops are growing well, the neighbors are hopefully peaceful, which is why humans would be fine with things as they are. We'd probably stick to basic tools and science. Of course, we're naturally curious creatures, so we'd still have some progress. It just would be very slow compared to our world. What sounds boring for some might sound awesome for us. Our life would be less exciting, but we'd be more united and peaceful. Maybe, in a world like that, we learn to treat each other with more kindness and love. But we can only imagine.
Suppose everyone in the world wants to do this, and countries started investing billions of dollars in this project. In that case, we can colonize the ocean floor. The question is, why would we need this? For the same reason we're going to colonize Mars, to save Earth from overpopulation. Why do we need to move to the red planet in the near future if we can live underwater? It'll be cheaper, safer, and most importantly, not far from our home. You don't need to stay in cryocapsules for years to wake up hundreds of millions of miles away from your planet. It's much easier to take an elevator down to the underwater city, hang out there, and enjoy the views of marine nature. Besides, staying on Mars will surely cause severe mental problems for people. Panic, stress, and the realization that you can't return to your home whenever you want can put serious pressure on your mind. It's better to live under millions of tons of salt water, and the reason why we have to do this is a need for more resources. There are about 8 billion people on Earth right now. Some experts think that when the number reaches 10 billion, the world will begin to run out of food, fresh water, and fuel. Agriculture and other industries simply won't be able to develop so quickly. Resources will be depleted, and people will have to do something to survive. The colonization of the ocean is an ideal solution to the problem. Firstly, we have very little information about the ocean. We've studied space much better than the ocean on our planet. Most likely, vast reserves of fuel are hidden under the seabed. Secondly, we will be able to reduce the load on our planet by about 50% if we move to live in the ocean. Thirdly, there will be no problems with logistics. Delivering food, necessary equipment, and construction materials will take hours, and if something breaks along the way, you can return to the surface and try to deliver it again. Sending things to Mars would be much more complex and expensive. Imagine that halfway there, millions of miles away from Earth, something breaks down on the spaceship with provisions. Then you'll have to wait for many years for the next delivery. But the main reason for ocean colonization is protection from disasters and natural cataclysms. Volcanic eruptions, radioactive winter, earthquakes, tornadoes, and floods. We could easily wait out any disaster underwater. Yeah, there are volcanoes on the ocean floor too, but the consequences of their eruptions are not so dramatic. The water immediately cools the lava and prevents ash from spreading. We will never experience the consequences of fire again. No burning forests and polluted air. And speaking about the air, there's a lot of oxygen in the ocean. More than half of the oxygen reserves on the planet are replenished by the sea, thanks to algae and phytoplankton. So don't worry, we'll be able to breathe deeply. The main thing is to figure out how to do it underwater. When humanity decides to take such a global step and begins to colonize the ocean, we will first have to adapt our bodies to high pressures. There's such a thing called saturation diving. Before descending into the depths, you must inhale compressed air. The nitrogen and oxygen quickly dissolve in your blood and exert pressure on your body from the inside. At the same time, the water pushes on it from the outside. In simple terms, your body is in balance and you don't feel bad. Divers use this method when exploring the seabed at great depths. Therefore, when people begin to colonize the ocean, they will dive there wearing cylinders with compressed air and an oxygen mask. The main rule is to surface slowly. You need to wait until the compressed air completely dissipates inside your body. If this isn't done and you rise to the surface, then you will feel intense pressure from the inside. Nitrogen will start acting in your veins like soda bubbles when you shake a can with the drink. After this adaptation, we will start building cities, roads, and stations that will transfer people to dry land and back. It shouldn't be too difficult because we already have the technologies needed for the underwater lifestyle. Welcome to the Aquarius Reef Base, located at the bottom of the Florida Keys Marine Reserve. This is a small laboratory where 6 people can live for 10 days. Scientists working there study coral reefs, marine plants, and fish. The lab doesn't look modern. It resembles a sunken, rusty bathyscaphe overgrown with shells and other underwater stuff. To create buildings with more beautiful designs, people will need new technologies for underwater construction. So let's imagine that global colonization has begun. Engineers use durable stainless metals and other materials capable of withstanding high pressure. With the help of freight elevators, people lower everything needed for large-scale construction to the bottom. Stations with such elevators appear in all the seas and oceans. Workers build huge underwater constructions on dry land. Then, large ships deliver them to the stations. From there, they descend to the bottom, where scuba divers and robots set these houses on the ocean floor. Every building is like a giant submarine with lots of apartments. They look ordinary from the inside, except for the underwater view from the window. To reduce waste emissions, engineers build huge capsules in every city, where garbage is destroyed by high water pressure. People try to live closer to the shore because they want to spend less time commuting. This causes severe pollution in coastal areas. Builders set up communication between the stations and land by creating vacuum tunnels with high-speed trains inside. In simple words, this is an underwater subway, only much faster than the one on dry land. From now on, people move farther from the shore to live in cleaner water. Humanity begins to make daily life in underwater cities more comfortable when the main construction is over. Scientists create filters that can quickly purify seawater. Now, everyone has a faucet that takes water directly from the ocean and turns it into fresh water. Also, constructors put in air filters capable of extracting oxygen from the water. Electricians create underwater mills to generate energy. To leave home, a person must put on a diving suit and cylinders with compressed air and exit through an airlock. People swim between buildings and talk to one another using radio communication. For faster movement, car companies produce small bathyscaphes with locked cabins and powerful propeller systems. Over time, engineers create large domes where you can walk and breathe fresh air, like on land. Global clothing brands develop fashionable diving suits and practical accessories for comfortable underwater movement. For example, you can attach a small heater to your clothes to not freeze while swimming. And you can also put on wider fins with engraved brand symbols. To make such a lifestyle as comfortable as possible, scientists and biologists create masks that work like gills and provide a person with oxygen extracted from the water. Constant exposure to high pressure changes people's physiology over time. In the water, we need to put more effort into moving. People who often leave their homes lose a lot of calories. They become slimmer and their muscles get stronger. Look at the Olympic swimming champions. Now, almost all underwater citizens have the same developed shape. Our body temperature is falling, and evolution slowly turns us into cold-blooded creatures. A lack of sunlight makes our skin paler, and we start resembling amphibians. We learn more about deep-sea creatures such as the giant squid and other monsters. Almost every month, scientists discover new species. But at the same time, many fish species disappear because of human activity in the ocean. The extraction of natural resources from under the seabed heavily pollutes the water. To reduce the load on the planet, people decide to colonize the sky. But this is a topic for another video.